Hello, and we're going to start today talking about percent daily value. I'm sure you've all had an opportunity to read the nutrition facts on the backs of different food labels. And they usually give some percent daily value numbers, and those are, for example, right there, the fat or the cholesterol or the sodium is given as some percent daily value. It's because the FDA feels it's important to know the percent composition of the food people are eating and provide that information to you. So in chemistry, it's also important to know the percent composition of the different elements in the compounds we're talking about. So we are going to learn how to calculate what we call mass percent of individual elements in a compound. So how can we determine this percent composition for elements in a compound? We're going to look at two steps. First, find the mass fraction for a given element. The mass fraction is equal to the mass of the element present in 1 mole of the compound, and we're going to divide that by the mass of 1 mole of the compound. That's simple enough. The second step is simply multiply by 100%. That turns our fraction into a percent. So let's practice so you can get an idea of what I'm talking about here. Let's find the mass percent for each element in ethanol. That's our formula for ethanol. So, first, we're going to find the mass fraction for each of the elements individually. So, let's look at the mass fraction. We're going to look at carbon first. We know that in 1 mole of ethanol, there are 2 moles of carbon. You see our formula right here? We have 2 moles of carbon. We have 6 moles of hydrogen right there, 6 moles, and 1 mole of oxygen. There's only 1 oxygen. So, knowing that, we can calculate the number of grams per mole, right? Remember our molar mass? It's the number of grams that is contained in 1 mole of a substance. So, let's start with carbon. The mass of carbon is going to be equal to 2 moles times its molar mass, 12.01 grams per mole. It's going to give us 24.02 grams of carbon. We have our mass of hydrogen. We can multiply 6 moles times its molar mass, our conversion unit, 1.008 grams per mole. That gives us 6.048 grams. And we can do the same for oxygen as well. That gives us, when we add all of the grams together, gives us the mass, the molar mass of our compound, ethanol. We have 46.07 grams in 1 mole of ethanol. So, what are we going to do with all of this information? Well, we are going to find the mass fraction. We needed to find the total mass for the molecule, and we needed to find the masses for the individual elements, and we've done that. Now we can find the mass fraction. Let's find the mass fraction for carbon. We're going to take the mass of carbon, 24.02 grams, and divide that by the total molar mass for the molecule, 46.07 grams. That gives us our mass fraction. For hydrogen, it's the same. We take the grams of hydrogen right here that we calculated, divided by the mass, the molar mass for the entire molecule of ethanol. And we do the same for oxygen. That gives us these nice little fractions here. And let's look at what we're going to do with those. This is the easy step. Let's take each one of those fractions, which I just simply rewrote right here, the whole calculation for each of those. And we take the fraction and we multiply it by 100%. That gives us our percent of each of those elements in the compound of ethanol. Note, mass percent is sometimes also called the weight percent. So now you try. Determine the mass percent of each element in sulfuric acid. And just in case you forgot, your nomenclature rules, I wrote that for you right there. So you can pause the video and see if you can find out how to calculate the mass percent for each of the elements. Here are the answers for those mass percents right here. If you didn't get the right answer, go back, see what you did wrong, look at those different steps and how you calculate those mass percents. If you'd like to do some advanced proficiency, try looking at how much sodium is in one of your favorite snacks. Look at the number of milligrams and then decide, calculate how many atoms of sodium that is. Find the percent composition by mass of sodium chloride and table salt. Kind of goes along with that same idea. Compare that to the percent composition of another salt, potassium chloride. And if you can come up with other great ideas, I'd love to hear about them. We'll see you in class.